Okay, so let us continue our discussion for the remaining parts ng ating review. So this is problem number 6. Nestle Dairy Products plant must cool 4,000 gallons of fresh milk. Yan 4,000 gallons. 4,000 gallons of fresh milk. Received from the plant, received from the farm per day. Per day daw, per day. So per day, 4,000 gallons per day. From the initial temperature of 80 degrees Fahrenheit to a temperature of 38 degrees Fahrenheit in 5 hours. So, meron kang binigay diyan in 1 day, okay, meron kang binigay na 5 hours. Pero, ito kasi, ito daw yung nare-receive niya per day, pero hindi yan yung pinapasok mo sa system mo. Ang pinapasok mo sa system mo is 4,000 gallons in every 5 hours. Yun yung palalamigin. If the density of the milk is 8.6 pounds to the gallon, specific heat of milk is lagi niyong kakabisaduhin 'to, yung specific heat of Nestle milk, dairy milk, okay? 0.935 BTU per pound degree Rankine. Hindi nagbabago 'yan, constant 'yan. CP of milk. Okay, Nestle, kapag sinabing Nestle or milk, 0.935 BTU per pound degree Rankine. Saka ko na sabihin yung mga sa fish, sa beef, okay, sa pork meat. What must be the capacity of the refrigerating machine in tons? Itong tinatanong, QA. Okay? Ano daw yan? Di ba ang QA natin, yung QA is equal to QREF, where QA is equal to MCP delta T. It is the what? It is the heat. Sensible heat. At constant pressure yan yung process. So, ito yung mass ng milk. Kaya lang wala tayong binigay na mass. Ang binigay sa'yo is the volume. Okay? 'Di ba? Recall natin that density is equal to mass over volume. Eh, ang binigay sa'yo is volume. Okay? Nagbigay din ng density. So, yung mass makukuha mo. Therefore, yung QA equal to volume times density CP delta T. Okay? Ilang beses na natin ginagamit ng formula na to. Then we can now solve. Okay? Ang hinahanap dito, in tons. Okay? TOR ang hinahanap dyan. Eh, lahat ba sila sir, naka-ano po sila, naka-English unit. So, di English units tayo. Problema ba yon? Okay? So, QA, binigyan ka dyan. Okay. Padadaanin natin ng, saan nyo gustong padaanin? HP ba o sa kilowatt? Sige, kilowatt na lang. Walang problema. Gawin muna natin tong seconds. Okay? BTU yan, di ba? Maging BTU. So, volume, 4,000 gallons. Okay? 4,000 gallons. Kulang na isang zero. Gallons. Ayan. Tapos, ilang oras yon? 5 hours. Okay? 5 hours times 3,600 seconds per 1 hour. Ayan. Tapos, 4,000 gallons, binigyan ka ng density niya. 8.6 pounds per gallon. 8.6 pound per gallon. Tapos yung CP, anong binigay sa'yo? 0.935. 0.935 BTU per pound degree Rankine. Sa change naman ng temperature, ano yung change ng temperature mo dyan, kaibigan? 80 to 38 degrees Fahrenheit. 80 minus 38 degrees Fahrenheit. So, Rankine na rin yan. Okay. Tignan natin. Anong lalabas dyan? Cancel all the same units. Gallon, gallon, pound, pound, Rankine, Rankine, hour, hour. So, seconds and then BTU. Ang kailangan mo dyan is TOR. Okay. Kunin natin yung kanilang mga conversion factors. So, ang malalabas dapat dito, kilojoule per second. Pero ang BTU, 1055 or 1.055 kilojoule, 1 BTU. Magiging kilojoule per second na lang, 'di ba? Pag kinancel natin si BTU. Kilojoule per second. Ayan, bilugan natin para hindi ka nalilito. Now, if that is kilojoule per second, naging kilowatts na. O, di yung conversion factor na lang ng kilowatt. 1 torr, 3.5167 kilowatts. O, di cancel natin yung same units, yung kilowatt din. O, di torr na lang ang natira. So, let us solve. 4,000 times 8.6 times 0.935 times 80 minus 38, I think that is 52. Okay, times 1.055 times 5 times 36 times 3.5167. The answer will be ilang TOR yan? Sinama ko ba 8.6? Ay, hindi pala 80 pala, 42 pala dapat. Ay, namalikmata na naman ako, kala ko 90. Kasi sinabi ko 80, di ba? May inisip ko 90. Okay, 42. Ayan. So that is, okay, the answer is, QA is 22.515 TOR. Tons of refrigeration ang needed in order to cool down the milk from 80 to 38 degrees Fahrenheit. Okay? That is for problem number 6. How about problem number 7? An air-conditioned room is being held at 24 degrees Celsius dry bulb and 60% relative humidity. Okay. So, a flow rate of 4 cubic meter per second of supply air at 18 degrees Celsius dry bulb and 80 degrees relative humidity is being delivered to the room to maintain that steady condition. What is the sensible heat absorbed from the room? From the room air. Ha? Room air. Okay. Air conditioning. Use standard atmospheric pressure. So, inahanap natin yung QS, sensible heat. So, MS, tapos CP, nung dry bulb high, okay, minus dry bulb low. Yan. Pero, hindi natin alam kung ano yung mass nung supply air. Hindi natin to alam. Saan natin malalaman yon? Binigyan ka ng, yung flow rate of supply air. Binigyan ka ng temperature. So, temperature ng supply, that is 18 degrees Celsius. Binigyan ka ng flow rate, volume, that is 4.4 meter cube in every second. Ano pang binigay niya? The pressure is atmospheric. The pressure nung supply, that is 101.325 kPa. Tapos, R nung air. R nung supply, di air. Yan yun. So, MS, daanin na natin dito. Okay? The mass of the supply air is equal to P, okay, nung supply, volume nung supply, R nung air, tapos yung temperature nung supply. Okay, ipasok natin to dito. Okay, para makuha natin yung sensible heat. So, QS is equal to PS, VS over yung R ng air. Hindi naman sinabing vapor, di ba? So, that is air. Tapos TS, okay, bracket, multiply natin ng CP nung air. Tapos, multiply natin yung dB nung hot minus dB nung low. Ayan. So, we can now solve. 101.325 kilonewton per meter squared multiplied to yung volume supply mo. So, 4 meter cube in every second. R ng air, that is 0.28708 kilojoule per kilogram. Kulang pa, degree Kelvin. Yung temperature, lagi po yan naka-absolute. Yan, the absolute ng temperature. Ano po ba yung supply mo? 18. Sinupply siya as 18 eh. 18 plus 273. O, degree Kelvin. Tapos, multiply mo na to ng buo. Okay? Multiply mo CP ng air, di 1.0062 kilojoule per kilogram degree Kelvin. Now, meron pa ba? Anong hinahanap dyan is in kilowatts. So, dB. Ano yung magiging hot air? That is 24 minus 18. 24 minus 18 degree Kelvin. So, cancel all the same units. Kilojoule per kilogram, Kelvin, Kelvin. Tapos, meter squared, meter may matitirang isa. Kilonewton, meter, second, that is kilojoule per second ang lalabas. Di kilowatts din. So, QS will be very basic. Okay? Ang pag-solve ko dyan, ganito na po dapat ang makasanayan nyo. Hindi part by part. Kasi, mahuhuli kayo pagdating ng board exam. 100 questions ang isosolve nyo doon. Okay? 100 questions, most of them solving. 80 to 90% solving. Konti lang yung terms. 5 items terms. Okay? Kailangan alam nyo na kung paano mag-solve ng simultaneous equations. Tapos, multiply natin ng 18 plus 273. Apply nyo tong way of solving ko 24 minus 18, I think that is 6. That is 29.29 kilowatts. Ayos ba? Napakadali lang ng ating ref and air conditioning. Ginagamit nyo lang yung mga fundamentals ng thermodynamics. Okay? Okay, so ito yung problem number 8. Calculate the amount of energy that must be removed to cool the air at standard pressure in a house. So, given na dito yung volume ng house. Ayan. 20 by 30 by 25 meters from 100 degrees Fahrenheit to 40 degrees Fahrenheit for a period of 4 hours. So, that is yung supply niya for the entire 4 hours. Now, the specific heat at constant pressure is 0.24 BTU per pound degree Fahrenheit per degree Fahrenheit. Use the average mass of air based on the two temperature readings. So, parehas lang to ng mga naging previous problems natin. First, ilista muna natin yung total volume nung nandun sa room. So, the total volume is 20 by 30 by 25. Huwag muna natin lagay yung unit. Tapos, yung period niya is in 4 hours. Given din dyan yung CP, which is constant nga pag air. And then, ano bang hinahanap dito? Amount of energy that must be removed in HP. So, that is Q. Okay? Since this is sensible heating, okay? And then, constant pressure, okay? Constant pressure heating and cooling. That is equal to Q, equal to M nung supply air, CP nung supply air, and then delta T. Okay? So, delta T, okay na. Yung CP natin, meron na. Ito na lang ang problema natin, yung MS. But it will come from this equation, yung ideal gas equation. PV is equal to MRT. Now, pagdating dito, pwede natin itong i-reform in order for us to solve yung MS. MS is equal to P nung air inside the room. Supply air to pinag-uusapan natin. The volume total na i-occupy niya divided by yung R ng air and then yung temperature ng supply, which is what? Okay, yung supply natin, hindi natin alam. Kukunin mo dito yung pinakauna, yung from 100, from 100 degrees Fahrenheit. Okay? So, 100 degrees Fahrenheit, i-convert na natin yan dito sa ating calculator. That is shift, convert to 37. Okay? Convert natin to degrees Celsius kasi lahat naman siya naka-SI. Okay? Alam din naman natin yung CP ng air kapag SI. So, this is, as is, pwede na to, 340. over 9 degrees degrees Fahrenheit tuloy, degrees Celsius. Okay, as is na 'yan. So, itong MS na 'to, puwede natin 'tong isa lang dito sa MS dito, okey? So, by simplifying it, puwede natin gawing PA V total over yung R ng A, supply air, you multiply that with CP of air, then, T2 minus T1. But in this case, nakalagay kasi dito from 100 degrees Fahrenheit to 40 degrees Fahrenheit. Ibig sabihin the cooling is removed, okay? Negative. The work is done out of the system, done by the system, ayan. Or the heat is given off, okay, by the system. So, negative dapat yan. Pwede magkabaliktad, pero yung negative dyan will just tell if the value is rejected or added. Okay. Pag sinabing from, nagmula, okay, to, pinanggalingan yan hanggang dun sa pupuntahang temperature. So, this is T1, okay, and then this is T2. So, this is the supply temperature. Okay, as is na to. Correct na yan. Okay? So, solving simultaneously, meron tayong pressure, standard daw, 101.325 kilonewton per meter squared. You just have to multiply that with the total volume na 20 by 25 by 30. Tignan natin kung tama yung aking pagkakalista. Yes, tama. And then meter cube kaagad yan. You just divide that with the R ng air. 0.28708 kilojoule per kilogram degree Kelvin. And then yung temperature na supply, that is 340 divide by 9 plus 273. Kailangan to naka-absolute temperature, that is degree Kelvin. And then the CP of air. Okay, kahit di mo na kunin yung 0.24. Pwede ng 1.0062 kilojoule per kilogram degree Kelvin. Now, the temperature change. Okay? We'll talk about the temperature change. Okay, so 100 tapos minus 40 or 40 minus 100. Pareho lang yon. Okay, naka-degree Fahrenheit to. Ang gagawin mo, i-divide it with 1.8 kasi para maging degrees Kelvin. Change in temperature eh. O ngayon, we cancel all the same units. Yung kilonewton, okay? Kilojoule per kilogram, degree Kelvin. Okay, kilonewton, meter. Okay, may kulang tayo. Hindi natin minultiply ito nung time that is given. Okay? I-multiply natin with yung, hindi, divided by time pala to. Divided by the time, total time. Yan. Divided by the total time. So, the total time is, nakalagay dyan, 4 hours. 4 hours times, gawin na agad natin, 3,600 seconds in every hour para maging kilojoule per second. Kasi magiging dito, titira dito kilonewton meter per second eh. We cancel all the same units. And then, kapag natira is kilojoule, magiging kilowatts. Okay? Naging kilowatts na yan. O, i-multiply natin para maging HP. So, 1 HP in every 0.746 kilowatts. We cancel again the same units. Itong kilowatt, yung seconds, meter, tsaka yung kilonewton. Now, we are ready to calculate the value. O, isang solving lang yan, di ba? Ganun lang kadali yun, sir. So, 101.325 times 20 times 30 times 25 divide by 0.28708. Okay? Times 340 divide by 9 plus 273. Okay. Times 1.0062 times 100 minus 40, I think 60, divide by 1.8. And then all in all, we divide it with 4 times 3.6. Ngayon ang lalabas diyan kilowatts pa lang 'yan, ha. Oh, anyari? Ayun, hindi ko nalagyan yung taas. Ayun. So, that is 39.67 in kilowatts. And then, meron pang nasa dulo, divide by 4, 7.746. 746, okay. The answer will be 53.18. Okay. Your power or the heat that is rejected to the system is 53.19 HP. Okay. That is for problem number 8. Let's go to the other problem. So, for refrigeration cycle, going to 9, yun pala hindi ko binasa ng maayos. Ay, dapat basahin niyo ng maayos. For a refrigeration cycle, meron tayong binigay na Hg, H2, and then mass flow rate of 1 kilogram per second with heat addition. So, heat addition, that is QA. Okay? Tama ba? Yeah. Heat addition. Determine the heat rejected per power. Mhm. So, ang hinahanap dito is COP nung heat pump. That is QR over work of the compressor. QA is given. So, meron kang MREF multiplied to H1 minus H4. Okay? Hanapin mo muna itong MREF. O, di COP, tapos meron ka bang work ng compressor dyan? Wala rin. Wala ka ring work ng compressor. So, isa-isahin natin. QR, work COP. So, QR is H H2 minus H1 over work ng compressor is QR is H2 minus H3. Dito H2 minus H1. Wala kang H3. Yun. HG, wala kang H3. Ito, dito mo isosolve. So, meron kang MREF. QA is 12 kilowatts equal to MREF. MREF is 0.1 kilogram in every second. Tapos H1, that is HG. Ayun o, 190.8. 190.8 kilojoule per kilogram. Wala kang H4. Where H4 is equal to H3. Ito ang hinahanap mo dito. Para mailagay mo siya dito. So, hanapin natin algebraically. That is 12 divided by 0.1. This is kilojoule per second. This is kilogram in every second equal to 190.8 kilojoule per kilogram minus H4. So, H4 ang hinahanap natin. Therefore, H4 is equal to 190.8 minus 12 divided by 0.1 kilojoule per kilogram. That is H4. Then, it is equal also to H3. Okay. Solve natin. 190.8 minus 0.12. Hindi, 12 pala yan. 12 divided by 0.1. The answer is 70.8. 70.8 kilojoule per kilogram. Now, we can solve for the COP ng heat pump. COP of the heat pump kasi heat rejected ang hinahanap. So, that is H1 or H2 minus H3. H2, ano ba H2 dyan? Okay. 220. 220 minus 70.8 divide by H2 minus H1. 220 minus 190.8. So, 220 minus 70.8 divide by 220 minus 190.8. The answer is 5.109 or 5.12. 5.109. Kapag sinabing heat rejected per power, ibig sabihin that is the COP of the heat pump. Okay? That is for problem number 9. How about problem number 10? Okay. A reverse Carnot cycle. Ito na, reverse Carnot. Baliktad. Reverse Carnot cycle. Okay, check ko muna yung sa choices. Okay. Requires 5 kilowatts of heat and extracts energy from a lake to heat a house. If the house is kept at 25 degrees Celsius and the heat added is 1,800 kilojoules per minute, what is the temperature of the lake? Reverse Carnot. So, heat added is Q. Ano ba yung binigay sa kanya? QA is 1,800 kilojoule per minute. Ito daw yung requirement, okay? 5 kilowatts. So, that is QA. Ito naman yung work ng compressor. Yan work ng compressor yan. 5 kilowatts. Requires 5 kilowatts of power for the compressor or the pump, heat pump. What is the temperature of the lake? Okay, binigay sa yung house. Ito yung temperature ng lake. So, how will we solve that? Okay. Ito yung T minimum. That is 25 degrees Celsius. Tignan nyo extracts energy from the lake to heat the house. If the house is kept, it daw yung heat of minimum. I-keep niya daw to minimum yung temperature na yan. Tapos yung lake, yan yung mag-absorb ng heat. How about the maximum temperature ang hinahanap dyan? Therefore, 'di ba kapag reverse Carnot cycle, T what? T max minus T minimum divided by T max. 'Di ba ganito 'yan yung efficiency, 'di ba? Simplify natin 1 minus T min over T max dito nagmula 'yan. Equal to 1 minus Q nung condenser over yung Q rejected, 'di ba? QR. QR, ayan yung QR. Tignan nyo yung work ng compressor is equal yan sa QR minus QA. 'Di ba? And then, in order for you to find yung QR is equal to work ng condenser compressor plus QA. Yun yun. I-add mo lang yung dalawa. So, QR over QA. Ngayon, in order to simplify this, anong hinahanap? Tmax, okay? Cancel na natin to, cancel natin yan. T minimum divide by Tmax equal to QR over QA. Anong hinahanap natin? Tmax equal to T minimum QA over QR. Let us simplify. Yung Tmax is equal to T minimum, that is 25 plus 273. Okay, degree Kelvin. You multiply it with QA. Ano yung QA natin dyan? Kilojoule per minute. Gawin natin kilowatts. So, 18,000 kilojoule per minute times 1 minute in every 60 seconds. Okay? And then, let us divide this with QR, which is itong value nito, 18,000 kilojoule in every minute multiplied to 1 minute in every 60 seconds plus yung 5 kilowatts. Oh, okay. Pero ang hinahanap natin dito, nandiyan is degree Celsius o di minusan na lang natin ng 273 para maging degree Celsius. Okay, let us solve. So, 25 plus 273, I think that is 298. 298 multiplied to 18,000 divided by 60. Okay. Tapos, sa baba, 18,000 divided by 60 plus 5. Okay. Minusan natin ng 273. The answer is parang may baliktad ako. T-max, T-minimum, QR. Baliktad pala 'to, baliktad. Nagkabaliktad ako dito. Dapat 'to QA, T-minimum, T-max, T-max. Okay. T-max is equal to T-min QR. Mataas kasi 'to, dapat QA 'to. Ayun. Do'n ako nagkamali. Q minimum QA over QR. QA over QR. Heat pump pala 'to. Bale 'to QR, QA. Ayun. Baliktarin ko na lang, plus 5 kilowatt. Dito, baliktarin natin. Okey. 'Yun. Dito lang tayo nagkatalo. Okey. Ayun. Plus 5, ayan. Minus 273. The answer is 29.9. Okay. 29.96 degree Celsius. Check nga natin kung tama. 35 divide by 30, 35 divide by 30. Okay. Times, 298. Minus 273. Ba't mali yung compute? Ayun, 74.6. Nagkakamali yung calcu. Kaya, ayun, tama na. 74 point, wala kasi choices Tama na siya. 74.67. That is for problem number 10. Okay? So, the videos will come out after this. Okay? The videos will come out after this. This is 18, bale ito 30 plus 5 tapos 30. Okay? Simplify natin. Okay? Hindi, okay na yan. Okay na pala yan. So, the videos will come out after this. That will be all for today. So, on the next meeting, ilalabas ko na rin yung 4 pang more problems. And, that will suffice for now. So, see you next meeting. Have a nice day. Bye-bye.